Hi, so we're back at the workshop, and today we're gonna give you an update about the story of our batteries, starting from the Kickstarter batteries and going all the way until our production units, which are here. And we will cover all components, a little bit of detail into some things, and you will see why we did all these changes and why you're getting a better product now. So I really hope you enjoy this, and let's go into detail. Come over. So the first batteries that you knew or got to know were our Kickstarter version batteries, which is this design that you already know, which said Ion on top. And for Kickstarter, of course, we had working prototypes, and it was manufacturable and it was possible to produce, but we knew at the time that a lot of things could be done better, especially if you want a robust kit and a reliable kit, but also safe. So when we visited our battery manufacturer just after the Kickstarter for our first trip to China, we got a lot of feedback from them, from their experience. They are a big battery manufacturer. They are very experienced in making strong and reliable batteries. So from their feedback, we redesigned a lot of stuff and worked with them until the final production units that we will go to. So now let's cover the Kickstarter version. So from Kickstarter, our battery was really different. It was 10 cells in a row. We call it a linear array. And the 10 cells would go here. This is not the exact battery that was going here. This is another battery that we use, but the 10 cells would go here, and this would be the top of the top cover, which is actually the bottom, because this goes upside down. And you can see that these batteries were really thin. They were 2 millimeters thick, and a lot of things needed to be made better for it to be safe and robust. The whole idea is that the battery had connectors in the front here, these connectors. This is the BMS from that era. And the connectors to the side to connect to other batteries for the cruiser and our configurations that you already know. And so the BMS was inside here. The connectors were like this. And the motor controller, which is this big motor controller here, had a heatsink that you already know, that with our logo, and this connector, which we used to call the gold finger, and this would go something like this. So it's like a cassette. We used to call it the cassette, just like a Nintendo cassette. And then everything is connected, and you connect it to the sides to other batteries. That had a lot of problems in that we will not go into detail because it's really long. But in terms of electronics, in terms of firmware, in terms of safety for the batteries, so we decided to change all that. Also, these connectors were really expensive, which is never good, and they were not easy to waterproof. So by changing from these connectors to the ones that we have now, it was a kind of a struggle, but in the end it was better because the connectors now you will see are waterproof and are very good. So yeah, from this design we had to do a lot of changes to make it better. Also, and one of the most important things is that this case was not waterproof either. And it had only 4 bolts, and the bolts were really far away from each other, so the flex was really a concern. Of course, this is just 3D printed, so the material here is not the same as the one that we would inject in the end, but still, the stiffness and sealing of this perimeter here was a concern at the time. So yeah, we had to move from this. To make this linear design work, we needed to make it a lot bigger and a lot beefier. So in the end, we were thinking, okay, look, so is it worth it? Can we go to another design that has a better form factor? And this is how we decided to change to a 2-row battery. Okay, so we're now into the 2-row battery. We decided to change from 10 cells like this to 5 and 5, and that allowed us to move to a much more convenient form factor, which is the size in relation to the height, width, and length. So as you can see, this battery is much more compact than this one. And as I said before, this one was not the actual size that it would end up being. It would end up being much longer. So for this one, this is this is a first prototype that we presented to you a long time ago, but this was already manufacturable, and this was already meeting our expectations in terms of strength and stiffness and sealing and so on. And you can see this was the first version, but the button here had a problem from the inside in terms of assembly and waterproofing. So to optimize the assembly process and to do the waterproofing better, we decided to move the button from there to here, which you can see here. This prototype is very similar to the final production units, and this is also a 3D printed version, and this has seen a lot of kilometers. And you can see in these prototypes that we already have an O-ring going all the way in the battery case, so the battery case is fully waterproof, well, IP65. So the design here is a lot better in many ways. It's also more compact, and from this point forward we will be putting the cells into what we call the cell rack, which is a structural array that allows us to put the cells like this, so you can see them there. These are not our cells, but it's a good example. And you can see that this way we can control structurally the cell array. We can control the cell separation and allow air to move or to be there between cells, so temperature control is a lot better, and structurally this makes much more sense. And so this goes inside of the battery like this, and it's fixed there. You can see once I put it in, it has some keys that it doesn't let it move, so it's really stiff. And so yeah, a lot of advantages. And we 3D printed a lot of prototypes and tested the waterproofing, tested a lot of stuff before making the molds, because the molds are really expensive. And you can see that from the 3D printing we can achieve very good details. So we could test a lot of different tiny things. And we could test a lot of details about the design, about material cutaways, and a lot of stuff. We could test the final actual bolts, we could test a lot of things, and the only thing remaining from this point, we would say, is the stiffness of the material, which, as you can see, this one is much more stiff than this one, but still the material is not the same as the one that we would use in the end. So, but it was a big step forward, and with these prototypes we ran a lot of time, we tested a lot and got very good results. So we moved to the next stage, which was machined covers. So this is 3D printed. You can see the difference in color and finish, and this is machined, and this is from a stronger material which is much more stiff. So with this, in this case, we could test a lot of different stress tests, impact tests, and see the waterproofing, see the response. So, and from this point we also got our first samples for the silicone covers, for the charger and for the USB, and we got our first samples of the button, which is the button that you will see later in the final units. So from this we could test the feel, we could test the stiffness, the resistance to punctures, and make changes to the final units that will be injected in molds, and the molds cost a lot, so yeah. So from the previous prototypes we completed the design for making the molds, which is the expensive step and the step that you want to take when you're pretty sure about everything. And we made the first injections. So this battery comes from our first injections. We injected like 6 or 7 batteries. And as you can see, these plastics do not have texture, and the color is not the same as the final. I will explain later why. But the battery, in terms of virtually everything else, is the same. So this is actually a working unit, and you can see that the final part is this one, and you can see the difference in colors, which this is a little bit more black than this one. This one has more glass fiber than this one. We tested both materials, and we decided that a little less glass fiber was better because it was strong enough but a little bit more compliant. So for puncture impacts like this, a concentrated impact in here would be better, a little bit of compliance, a little bit of rubbery feeling, let's say. So everything that you see from here to there is our final units for everything. These are our final connectors. You can see that the pins are injected into the plastic bracket that holds the connector in place. So it's really easy to seal everything, and the connector is fully waterproof. And this is the female connectors that match this, that go into the bridge, which is a part of the carbon fiber plate that we will cover in the next update. We will explain in the next update, we will explain the carbon fiber plates and how it mounts to the skate and how everything works, so you can really understand the product that you will get. And yeah, so the final batteries are this. You can see here the final plastic units from the injection. These are actually units virtually from production. These are from the same batch that you will be getting your batteries. And here you can see one of our self-made prototypes. This is not from production unit, but a prototype from us. The final production, actual production BMS. And we already showed you this is a final production motor controller. So you can see the difference in size. Let me bring the previous BMS here and the previous motor controller, or the first motor controller here. So the difference in size, you already know the advantages of a smaller motor controller. It will make it more light for you, it will make it more compact for you, for travel, for just packing, and etc. So, okay, so we're on the final production units. Let's go a little bit into detail about them. The material is really stiff, as you can see. It's nothing like we had before. We have very good detail in the injection process and everything, so we get a very good sealing out of this, and the battery is super stiff and super strong. You can really hit this really hard and nothing will happen. So an important feature about all this is that we made a huge effort into making it compact but still solid and strong. So you will get a very nice battery. And these are the final buttons. It has our logo laser cut there, and we'll show you a cool feature about that. And these are the final silicone inserts for the USB and DC port. So when you have your batteries like this, and you want to know the state of charge, you just press this button like this, and it will show the state of charge like this, so you can know pretty quickly if you can leave the house or you need to charge it, because if you're going far away or nearby, you have a quick estimation. So you can see this one is pretty much fully charged, and this one is almost dead, almost empty. So it will show the state of charge from green to red in a gradient, in a continuous gradient, going through yellow in the middle. And so it's pretty easy to see the difference between these two. So if I have these two batteries in my house and, oh, this one is almost empty and this one is almost full. So it's pretty easy. If I turn it on, I just leave this button on for a second, and then it will turn on and start doing like this, like going off and on smoothly. And this is showing that the battery is on. You have USB power here, but it is not connected to anything. It is by itself. We call it like tabletop mode. So in the tabletop mode, it is by itself and it is safe. The connectors are completely turned off. There's no power here, so it is completely safe. And what happens, how do we know that it is ready to go when we connect it? When we put it into the motor controller like this, the light will stay on there. So this means that the motor controller is powered up and it has connection with the battery and they're communicating. And now the power pack as a unit is ready to go. It only needs Bluetooth communication to give power to the motor. So it's pretty straightforward and pretty simple to use. And to turn it off, you just need to leave it pressed the same amount of time that you press it to turn it on. And when you see that magenta light, you just release the button like this and it will go off. So it's pretty easy. It's pretty easy to use and it's pretty easy to understand, and that's pretty much it. Remember that from the first time that we made the battery 2-row, we changed the mounting bolt so that it works with a standard T-tool. So to put your battery in and out, you just need a T-tool like this, a standard T-tool. We will provide you with one, but any skateboard tool can work. So And you can assemble the full skateboard, including motor and everything, with the tool that we will provide. So that is pretty cool. And yeah, so the battery, the final unit is really strong. The button feels really nice. The connectors are waterproof, and everything works as we want it to. Okay, so I really hope you enjoyed this update. If you have any more questions about the battery and the storyline, just let us know. In the next update, we will let you know a little bit more about the carbon plates, how they work, how they install to the skateboard, how they don't fall off when you're running. Don't worry, everything can be done with the skateboard tool, so it's pretty easy for you. And we will also discuss a little bit about a trip that I had to China last week. I spent the full week in the battery manufacturer factory, doing the trial production of the batteries and discussing a lot of details for the mass production which will come in 2 weeks. We will go to China again in 2 weeks to do the first batch, so 700 batteries that will be produced, and we will be there for that. So we will let you know an update about all that very soon. So stay tuned, and if you have any questions, just let us know.